Hey guys. Alright, so we're going to go over some of these problems, and what we're working on, the topic of it is going to be graphing the intercepts of lines, moreover graphing entire equations of lines. Now again, before we get started, I really want to emphasize this is a very high level skill. There's many things that are going on within this, many sub skills we've been cultivating to get to this point. And if any of those skills are weak, you're going to have to work on those until you can truly master this new material. And what I'm going to try and do is do my best to break it down into all of its parts, so that way you can see which part is which, and also kind of realize, which part you may need to work on. So, alright, so when we get these equations, there's really three things that are going on here. So, the first thing is that we need to find both intercepts. And now, what are the intercepts? Well, we could have a x-intercept, and we could also have a y-intercept. Okay, so when I say find the intercepts, I'm actually asking for two jobs there, right? There's two things that you got to do in order to find those. Now, if you notice, it also says and at least one other point. So that's throwing a third thing onto this question that you got to do, and it's just one other point. Right? Now, what does that point need to be? It doesn't specify, so that means it's up to you to choose which point it will be. Okay, so we have a little bit of freedom there. We can try and make our lives easier by using some of that freedom to find a number that's a little bit easier to find. But right now, as it stands, we already have three things we have to do with this problem, so that, make no mistake, that can be quite a bit. So, alright, so how do we get started with this? Well, the one other point might be the easiest. So we can go ahead and start there. Now, what's a number that I can choose to make a point with? How about x equals 1? 1 is a pretty easy number. It's a pretty friendly number. If you were thinking about choosing 0, you'll see why we didn't choose that in a second. But x equals 1 works really well. You could also do x equals 2, x equals 3, any other number. So again, what we're going to do, so we are going to now take this equation which relates x and y, and we're going to take the 1 that we just made, right? That 1 is equal to x, and we're going to plug it into where the x is right there. So now we're going to have y equals 1/2 times 1 plus 2. Okay? And when we get this, you're going to have to ask yourself, you're going to have to say, what do I need to do to now find my missing variable? Right? Because there's one missing variable in here, and it needs to be found, it needs to be calculated, and you have to ask yourself, well, is this thing isolated? And yes, it's already isolated, so we don't have to do any equation solving. Now, do I know exactly what it equals? And when I say that, I mean, do you know exactly what this number is? Like, is there any computation to be done? And obviously, there's some computation to be done. We can't quite say what it is until we do this calculation. So we got to go ahead and do that calculation, and then that finds our one other point. Right? How did that work? We took our x, we plugged it in, it then allowed us to find out what y was. So I'm going to do this calculation. 1 times 1/2, that is just 1/2, plus 2. Remember, when I want to add a fraction with something, it also has to be a fraction. So I'm going to make that a fraction over 1. And now they need to have the same common denominator, so I'm going to multiply the top and bottom by 2. So I will have 1/2. They will both have 1/2, so I put them both over 1/2, plus 4. So 1 plus 4 over 2, which is then equal to 5 over 2. And if you want to calculate that, 5 over 2 is just about 2.5. Okay? And so just like that, we went ahead, we found the y value that went along with that x value. Right? I just picked out the number 1, and it turned out the y value was 2.5. So now we can go ahead, we can put this on our graph. So we go over 1, up 1, 2, and a half right there. Okay, so again, right, that was one part out of this whole question. I know there's a lot layered here. These are very good exercises for you, but definitely don't make don't mistake these as easy. There's a lot of stuff to work on. Alright, so I guess now we can talk about the y-intercept first. Now conceptually, you need to know that the y-intercept is always going to have x equal to 0. And why is that? That's because if I went ahead and I chose any point along this y-axis, it would not have been shifted over left or right anything. Meaning that the x value for any point on this would be 0. And if that's kind of hard to understand, think about it like this. If I pick this point, how far left and right did it go? 0, right? If I pick this point, how far left and right did it go? It went 0, right? If I pick this point, how far left and right did it go? And hopefully you see the pattern, right? No matter where I go on this line, x is always equal to 0. So therefore, I start off my y-intercept by having x equal to 0. Now notice, I didn't get to pick that point, right? And that's why I didn't choose x equals 0 over here, because if I did, I would have secretly been finding the y-intercept. So you're not really choosing your point, you're more told which one to find kind of in code, right? Because when someone says y-intercept, they secretly mean x is equal to 0. So now we can go ahead and carry on just like we did with this process, except now x is equal to 0. So I'm going to write my equation again, and this is just out of good habit, so I know I'm always working with the same equation. And now I'm going to plug in 0 for this. So 1/2 times 0 plus 2. Okay, right, y is right there. I can go ahead and calculate it. 1/2 times 0 is 0 plus 2, which is equal to 2. Beautiful. So that means I plug in 0, I get out 2. So I'll go over 0 and up 1, 2, and plot that dot right there. And that is my y-intercept. Okay? Alright, so now, one last job that we gotta do, we have to go ahead and find the x-intercept. Now, there's a parallel to the y-intercept with the x-intercept. Notice the y-intercept had x equal to 0, so maybe, you can just kind of recognize the pattern, right? The x-intercept, or x-intercept, x equals 0, y-intercept, what must be there, right? You can kind of see y-intercept, x equals 0, x-intercept, therefore, y equals 0. Right, and that's good if you can see that pattern, but now let's talk about why that is. Why is this happening? Well, again, it's because if I say choose an x-intercept, it's going to be anywhere along that line, right? And so now, let's say I choose this one. How far up and down did that point go? Well, it didn't go up and down anything. Likewise, if I choose this point, how far up and down did it go? Didn't go up and down anything. And this one, right, doesn't go up and down anything. So any x-intercept is always going to have y equal to 0. Again, it's like a little secret code. Someone says find the x-intercept, they mean y is equal to 0. So now we'll go ahead, we're going to write our equation, and we are now going to have y equal to 0. So now this one's a little bit different, and you're going to see it's going to take a little bit more work because of that. But notice y is equal to 0, right? So where is that 0 going? Is it going where the x, or is it going where the y goes? Right, this one's different. It's going to go right here where the y goes. 1/2 x plus 2. Okay, now why is this one a little bit more challenging? Well, because notice we don't have our variable solved for. Right, over here we already knew y was on its own. We just had to calculate it. We found out what y was. This, x is kind of buried underneath these operations. And we're going to have to solve in order to find x. We're going to have to do inverse operations to get rid of this plus 2 and multiply 1/2 in order to find out what the x is. So let's go ahead and do this and realize you're using your equation solving skills right now, the thing we worked on last lesson. And so if this is a little bit rough for you, that's okay, but understand this is the skill you want to work on. This is the skill that's holding you back. This is what you can build if you're struggling. So, alright, we subtract 2 from both sides. And now, why did I do that? I had a plus 2. I want to get rid of that first. Remember, we're going backwards, so usually we do multiplication first, but now we want to get rid of addition first, because we're going backwards with our equation solving. So now we have a 1/2 that's multiplying x. Now there's a couple ways to think about this. I think this is the easiest. When we see a 1/2 that multiplies x, realize that could also be thought of as x divided by 2. Okay, and now that's a little bit easier. When you see something that's dividing x, what do you do to get rid of that? Well, you're going to multiply it. So we're going to multiply that side by 2, and we have to be fair, so we also have to multiply the other side by 2. We now go ahead, negative 2 times positive 2 is negative 4, and 2 over 2, well, those cancel and leave us with x. So we see that when we plugged in 0, x was equal to negative 4. So right when y was 0, and remember, remember when y was 0, right, this is a kind of y. We can think of this just like y. Darn it, sorry. We can think of that as a kind of y. Right, so when y was 0, x is now negative 4. Okay, and this is kind of what we saw in class the other day, how we did x is 0 and y is 0. Okay, so we'll go ahead, we'll do a couple more examples of these. I'll even go over some homework problems for you guys. But it's going to be the same concept over and over again. And if you can kind of, if this is hard for you, I would identify which of these 3 jobs is hard for you and bring that to class so that way we can work on it. Alright, so same deal. Got 3 jobs going on. I'm just going to highlight them again, right? So another point, so one other point. And I'm going to need the x-intercept. And I'm going to need the y-intercept. Okay, so this time I'll go ahead, I'll start with some of my intercepts. So my y-intercept, I do need to remember, if I have a y-intercept, that means I'm on the y-axis and I have not gone left and right. Therefore, x is equal to 0. I can now have my equation, y equals negative 1/3 x minus 6, and I can go ahead and plug in 0 to this equation. So negative 1/3 multiplied by 0 minus 6. Okay, so again, y is already isolated, so this one's a little bit easier. We don't need to do any algebra to it. And we can just go ahead and calculate that to be negative 6. Because negative 1/3 times 0 is going to be 0. Minus 6, well, that brings us to negative 6. So y is equal to negative 6. That is our y-intercept. So we have 0, negative 6. Right? We started with 0. We got negative 6. And that concludes our y-intercept. Now let's go ahead and find our x-intercept. So x-intercept, remember, if we are on the x-axis, how far up and down did we go? Well, we went up and down 0. So y is equal to 0. And now let's go ahead, we'll write our equation. We have y equals negative 1/3 x minus 6. Okay, and so y is equal to 0, so where are we going to put that 0? We're going to put it right here. Negative 1/3 x minus 6. Okay, so now we notice again, x is not solved for, and we're going to need to do the math in order to solve for it. So I'm going to start off by subtracting, or sorry, not subtracting, I'm going to add 6 to both sides. And why do I do that? Well, because I see a subtraction of 6 there. I know that I want to get rid of that first. And so I'm going to add 6 to get rid of a subtraction of 6. So 6 is equal to negative 1/3 x. Again, remember, if we see a fraction of negative 1/3, or any fraction in particular, you can think of that as kind of the denominator dividing the thing that it's multiplying. So negative x over 3 is how we could write that. Because the negative 1 would multiply with x, and then the x you could think of as having a denominator as 1, and so they would multiply across and they could give you negative x over 3. So now we have 6 equals negative x over 3. I have x being divided by 3, so I want to get rid of that. I'm going to go ahead and multiply that by 3. That means I also have to multiply the other side by 3. And so that's going to give me 18 is equal to negative x. And negative x, well, how can I get rid of that? I can just divide by a negative, or divide by a negative 1, and that will take care of the negative. And anything divided by a negative, well, that, and we'll go ahead and show the work right there. Positive divided by negative is going to make a negative 18. and then the x becomes positive because it's a negative divided by a negative. Okay, so we find that when we plug in 0 for y, or f of x, another way we could talk about it, x is equal to negative 18. Okay? Alright, so that's job 2 of 3 done. Now let's go ahead and do the third one. So we're going to find one other x point. I'll go ahead and now this is going to seem maybe like a strange choice, but you'll see why I do it in a second. So I'm going to choose x equals 3. And again, you can choose any number you want for this, but you'll see why I choose 3. So our equation is still the same. It's y equals negative 1/3 times x minus 6. And I'm going to go ahead and plug in 3 for x. So I have negative 1/3 times 3 minus 6. Okay, and so now notice it's easy to calculate for y. Y is set equal to all this stuff, so I can just calculate the stuff on the right and I get what y is. Now why did I choose 3? Well, you see that this is multiplying by negative 1/3. Well, think about it like this. If I have 3/3 of something, or 3/1/3 of something, how many do I have of it? Well, I have a whole of it. So that's just going to equal 1, or 1 whole. Now, how could you do that with the math? Well, you could think 3 over 1 will multiply negative 1 over 3. And then when you multiply those, you'll see you'll have negative 3 over 3. And we know that anything divided by itself is just equal to 1. So y would be equal to, it would stay negative because we only have a negative on top, only a negative divided by a positive, and then anything divided by itself becomes 1, and then the minus 6 comes down. We calculate that, negative 1 minus 6 is negative 7. So y is equal to negative 7. So we plugged in 3 and we got out a negative 7. And on the next, we're going to start working on homework problems, so we'll have more room to do these. But yeah, so we'll be able to spread them out some. So we'll go over 3 and down 1, 2, 3, 4, 5, 6, 7. This thing is going right to the edge. Then we go over 0, down 1, 2, 3, 4, 5, 6. Right there. And our x-intercept is going to be way over at negative 18. So it's going to be way out there. We're actually not going to be able to graph it because it's going to be so far over. But the line's going to look something like that, and we can sketch it going over something like that. Okay, and I also just realized we didn't draw the line on this previous equation. We didn't connect the dots on it or put that other point on here. That's not too difficult, but that point would go there, and we would draw our line straight through, just like that. Okay. Alright, let's go ahead and skip to some of the homework problems. Alright, so I guess we can start off the first one. So question number 1. So notice it's the same instructions. Sketch the graph of the line by finding the intercepts and at least one other point. Okay, so we're going to do the same thing. We're going to find the intercepts and at least one other point. So I'm going to look for the x-intercept. Now remember, how do I find the x-intercept? Well, I'm going to set y equal to 0. And then I can go ahead and plug that into my equation. So my equation is right back up here. So I'm going to have 0 is equal to x plus 4. So what is the missing variable here? It is x. And I need to go ahead and solve for that because it has stuff around it. So I need to get rid of that stuff. I'm going to subtract 4 on both sides. And then that shows me that x is just equal to negative 4. Or negative 4 would bring this equation back to 0. Alright, so that's our first point. We can go ahead and graph that. So if we made a table for this, and I guess we can put the table right here, with our x's and our y's, we would see that we have a -4 for x, and we have a 0 for y. And that's our x-intercept. So we go back 4, 1, 2, 3, 4, and we go up 0, so it would be right there. Okay, now let's go ahead, let's find our y-intercept. So for the y-intercept, x is going to be equal to 0. We're going to plug that into the equation, so we will have y equals 0 plus 4. Y is already solved for, it's already calculated over there, we just need to, or it's already on its own, we just need to calculate it. So 0 plus 4 is 4, and y is equal to 4. So we see our y-intercept is just going to be 4. So we plug in 0, and we get out 1, 2, 3, 4. Just like that. And you can see the dots as we start to connect them. But let's go ahead, let's get one other point on here. And that's going to help confirm our suspicion of the line, where we should know that these points will line up in a line in order to make an equation. In order to make a line. If we see that the dot doesn't really fit where it looks like it should, or it doesn't make a straight line, we might have messed something up. So we have one other point that we're going to find. I'm going to go ahead, and this time I'm actually going to choose -1, because I want to find a point that's going to be between these to verify that my line will go like this. So I'm going to choose x equals -1, and again I go back to my equation, and I plug in x equals -1. So I have y equals -1, because I plugged that in for x, plus 4. Okay? And now notice y is already solved for, so I don't need to solve it, I just need to calculate it. So -1 plus 4 is going to be a +3. So when x is equal to -1, y is equal to +3. Let me go ahead, I've been graphing these points, but I haven't been putting them in my table. Let me also put them in my table. I have -1 and 3, and I have 0 and 4. Okay? I put this on the graph, and it looks like this. And that's good, right? I see these 3 points, they line up to make a line, and that looks good, right? It's a line. Alright, let's do this again. So I'm just going to clear this page, and we'll now work on problem number, we'll pick another one on here. And how about we do 3 of them? 3 of them sounds good. That'll leave the other 7 for you. So we'll go ahead and erase all. Alright, so which one do we want to work on? Let's go ahead, let's take question number 3. 3 is a good one to work on. And then after that we can go ahead and work on one of the later ones, because they do get a little bit harder as they go on. Alright, so we'll do question number 3 now, right there. And so, remember, same deal, so the instructions are still the same. We need to find the intercepts, we need to find one other point. So we're going to find our x-intercept, and we know for the x-intercept, y is always going to be equal to 0. So we'll go ahead, we'll take that equation, we have 3x plus 0 is equal to -3. Okay, so what's the missing variable? What do we need to find here? We need to find x, and it is not isolated, so we do need to solve for it. We're going to use some algebra skills here. So we have 3x equals -3. And then we see the 3 is multiplying x, so how do we get rid of it? Well, we're going to divide by 3. And we're going to be fair, we have to do that to both sides. So I have x equals -1. Okay, so I plugged in 0, I got out x equals -1. So in my table, I'm going to write x is equal to -1 and y is equal to 0. Now let's go ahead, we're going to find the y-intercept. And to find the y-intercept, we know that x is going to be equal to 0. So I'm going to go ahead, go back up to the equation, and plug in 0 for x. So 3 times 0 plus y is equal to negative 3. I now go ahead, I can calculate this. 3 times 0 is going to be just 0. So 0 plus y equals negative 3. And then 0 plus y, well, that's still just y, is equal to negative 3. So I see that y is equal to negative 3. So that means my coordinate is 0, negative 3. Okay, I'm building up my table. We can go ahead and graph these once the table is made. And the thing is that these all represent the same thing. The table, the equation, and the graph, they're all talking about the same idea, which is this relationship of x and y. So it doesn't necessarily matter the order that you do this, because all three things represent one another and they talk about the same thing. So you can make the graph, then make the table, you can make the table, then make the graph. We're even going to learn how to have a table and make an equation from that. And you're going to see there's many different ways to write an equation. So we have this right here, and we'll go ahead. We're going to find one other point. So finding that one other point, we're going to go ahead, I say, how about we pick, let's pick 1. Let's say x is equal to 1. Okay, and so I'm going to go back to my equation. I plug in 1 for x plus y is equal to negative 3. Alright, and now I'm going to go ahead and, so I first have to calculate 3 times 1. That's not hard to calculate, but you do got to technically calculate that first before you go forward. So we calculate that, and now we see that our missing variable is y. We have to solve for that. So there's a plus 3 that's being added to y. So I want to get rid of that positive 3. How do I get rid of a positive 3? Well, I subtract 3 from both sides. So I have y is equal to negative 6. Okay, so the point I plugged in was x is 1, and then y was negative 6, so 1 comma 6 is my coordinate, or sorry, 1 negative 6 is my coordinate, and I can now go ahead and graph these. So I'm going to go back 1 and up 0. I'm going to go over 0 and down negative 3, and then I'm going to go over 1 and down negative 6. And that's good, right? This looks like a line that tells me that I did this correctly and that I didn't make any mistakes. So I can imagine my line looking something kind of like this. Beautiful. Just like that, you graphed a line, right? You used the intercepts and you found another point to go ahead and make that line. Alright, let's go ahead. Let's do one more. And how about we do question number... What'll be a tough one? How about we do question number 10? That's kind of like a final boss problem. It's a hard one. Alright, so number 10. Let's go ahead and walk through this. So it's the same deal as before. We're looking for the x-intercept. We're looking for the y-intercept. And we're looking for the one other point. Okay? Now, I guess I'll go ahead and I'll start off the x-intercept. It doesn't matter the order you find these. They will not change depending on the order that you find them. So we'll go ahead and we'll start with the x-intercept. And for the x-intercept, remember y is equal to 0. We turned off y to find the x-intercept. So I will now go ahead and plug in 0 for y into the equation. So I'll have 12 is equal to 9 times x minus 6 times 0. Well, 6 times 0, I know that's just going to go to 0 and leave me with 9x right there. So 12 is equal to 9x. I have 9 that is multiplying x, so I want to get rid of that. How do I get rid of multiplication? I divide, and so I will do 12 divided by 9. So that'll be equal to x, because our 9's cancel. And then 12 divided by 9, I can reduce that to 4 over 3. So 4/3 is what x is equal to. I'll go ahead and start logging that into my table. So I have x, I have y, and 4/3 is x, and y was equal to 0. Okay, so I'm going to approximate over 4/3, which would be right about there. It's a little bit over, a little bit more than 1. It's about, 1 1/3, so I'll approximate right there and go up 0, so then my point should be right about there. Okay, let's go ahead and find the y-intercept. So the y-intercept, remember, x is now going to be equal to 0. So I'm going to plug in x equals 0 to the equation. I have 12 is equal to 9 multiplied by 0 minus 6y. And I see 9 times 0, well, that's easy to calculate. Let me go ahead and get rid of that. And I have 6y is equal, negative 6y is equal to 12. So I can now get rid of this negative 6 that's multiplying y by dividing by a negative 6. I divide both sides by negative 6. My negative 6's cancel, and 12 over negative 6 is equal to negative 2. So y is equal to negative 2 when x is equal to 0. And it's going to look like that. And notice, right, that's kind of how this works. It's the idea that there's a particular x that goes to a particular y. And these things always relate to each other. And each one has a one-to-one relationship. Meaning that when I choose a particular x, in this case 4/3, it goes to a y that is 0. Or when I choose an x is 0, it goes to a y that is negative 2. These numbers relate to each other. Alright, let's find one more. How about we go ahead and choose x is equal to 1. We don't want to make it complicated for ourselves, so I'm just going to choose x equals 1. And now I'm going to go ahead and calculate this. So I have 12 is equal to 9, and I said x is 1, so times 1 minus 6 over y, or 6 times y. Okay, 9 times 1, I can calculate that. That'll be 9 minus 6y, and 12 is on that side. And now I'm going to solve. I notice I need to solve for y, so what do I need to do to solve for it? Well, the 9, it says 9 minus 6y, but I realize that that is a positive 9 that is acting on the negative 6y. So I need to get rid of a positive 9. How do I do that? Well, I can take 9 away from both sides. So if I take 9 away from both sides, well, 9 minus 9 will now cancel. And then 12 minus 9 will be 3 is equal to negative 6 times y. How do I get rid of the negative 6 that's multiplying y? I'm going to divide both sides by negative 6. My negative 6's will cancel. And y will be set equal to 3 over negative 6, or just negative 1/2, is what that fraction will reduce to. So y is equal to negative 1/2 when x is equal to 1. So x is equal to 1, y is equal to negative 1/2. And I'll go ahead and I'll plot these two other points that I haven't graphed yet. So my second point was over 0 down 2. And my third point was over 1 down about 1/2, down about to right there. And notice that, right? Even approximating, these things look pretty accurate, right? I can draw a line that's going to go something like that, which is good, right? It's a pretty good looking line. It looks convincing. It looks like a line to me. So those are some of your problems. Go ahead, attempt all of them, try your best on it, and bring them into class. The ones you're not sure on, we will continue to work on. All right, bye.